On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, we're going to look at three examples that are very similar with a definite integral. We have a basic trig example, but this is going to help build that foundation of where you have areas above the x-axis versus areas below the x-axis. We'll also come back after each example and look at these areas on a TI-84 so that you can visually see areas above the x-axis and areas below the x-axis. So for all three of these, we have definite integrals, but I'm just going to look at the indefinite integral of sine of x dx. And the derivative of cosine is negative sine, so the antiderivative of sine of x, this is going to be a very common one, is negative cosine of x plus some constant c for an indefinite integral. So this is what we want to use for all of these examples, but since we have definite integrals, we need to apply these bounds. So the definite integral of sine of x from 0 to 2 pi is going to be negative cosine of x from 0 to 2 pi. And then from here we take 2 pi, we plug it into x. Let's also take 0 and plug it into x. And don't forget we need to subtract these two values. Therefore, we have negative cosine of 2 pi. Well, cosine of 2 pi is 1, so we have negative 1 here, minus, bringing that subtraction on down. Cosine of 0 is 1, but then we have a negative cosine of 0, so that's negative 1. Simplifying this down, we get an area of 0. Now, why do we get an area of 0? Got to be careful with your signs here. Let's look on the TI-84. I had the function sine of x. I am in radian mode. And for this function, let's zoom trig, zoom 7. There's our curve. And we want to find the definite integral from 0 to 2 pi. Here's 0, and when you zoom trig, each little tick mark on the x-axis represents pi over 2 units. So here's 0, here's pi, here's 2 pi. Well, let's look at this. The area above the x-axis appears to be identical, and it is, to the area below the x-axis. However, when you have areas above and areas below, we have positive areas up here, negative areas down here. So essentially, they're canceling each other out. To show you that, let's press second, trace, go down to number 7. Our lower bound, lower limit is 0. Our upper limit is 2 pi. And notice it's tracing those two pieces. The area above, this is a positive number. The area below is a negative number. And since they're the same, they're canceling out. That's why our area is 0. With that said, here's 0 and here's pi and here's 2 pi. What is the area from 0 to pi? That's what this second example is showing. So we pretty much have the same piece here, except our bounds are different. Let's take the pi and plug it in. So now we have negative cosine of pi. Let's not forget to subtract. Let's plug in 0, so we have negative cosine of 0. And now to evaluate this, the cosine of pi is negative 1 times that negative 1 out here up front. We have a positive 1 there, minus negative cosine of 0. Well, cosine of 0 is 1, so we have negative 1 here. And now when we combine these, 1 minus a negative 1 is 1 plus 1, so our area is 2. So we have the same curve, sine of x, and remember now we're going from 0 to pi. So the area between 0 and pi, that's a positive area, and it turns out to be a nice number. It's 2. Let's verify that. Second trace, 7. Let's go from 0 to pi. And notice we get an answer of 2 right there. So the area up there is 2. That means this area down here should have been negative 2. That's what made them cancel out in that first example. Now, let's think about this last one without even doing the actual calculus. If this area is 2 and this area is negative 2, notice we're going from 0 to 3 pi over 2. So here's 0, here's pi over 2, here's pi, here's 3 pi over 2. So really we're talking about all of this section here and half of this section here. Since this area up here was a positive 2, all of this down here is a negative 2. But since we want half of it, really we're going to be thinking about negative 1. So if we have 2 up here and a negative 1 for this little half, 2 minus 1, we should get an answer of 1 for this problem. Let's see if we get that. So we have the same antiderivative, just new bounds. Plugging in 3 pi over 2. Let's not forget to subtract. Let's plug in 0 again. And when we evaluate this now, let's see if we get the positive 1. So cosine of 3 pi over 2 is 0. Well, that's negative 0. That's still going to be 0. Don't forget to subtract. Cosine of 0 is 1. We have a negative 1 here. Therefore, when we combine this, 0 plus 1, notice we do get an answer of 1. And let's make sure we visually understand that. We're going from 0 to 3 pi over 2. We've already said this entire area here is 2, and half of this is going to be negative 1. So 2 minus 1 gives us that answer of 1. Let's verify that. Second trace, number 7. Let's go from 0 to 3 pi over 2. And notice we get an answer of 1. We have a positive 2 and a negative 1. That's how we're getting that 1. And there you have it, a basic trig example involving definite integrals. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.